Welcome, everybody. We're going to be working on the remainder of the Module 6 slideshow tonight, and we left off at slide 56. We talked a little bit about some of the concepts that we already learned prior to starting the recording here, just reviewing some of the terminology and stuff that goes with classes. And now we're resuming on slide number 58 here, where we start talking about constructors. Constructors are something we've already been using, and we even used them a little bit before we reached, this module, before we formally learned about objects and classes out of necessity, basically. But now we're going to see that we don't have to operate with a default constructor. We can actually construct a constructor, if you will, and customize it to serve our needs so that our programs and objects behave in ways that make sense to us. So when we do call a constructor, as it says here, it's a certain type of method that's automatically called when an object is created. And, why do we call it a method? Well, there's parentheses there, right? Because so it's calling some sort of a method inside this thing called rectangle that creates the object for us from the blueprint that we have, right? And what it does basically, the constructor, as it says here, it initializes the object and it assigns default values sometimes automatically. Now, the ones that we created, we didn't have a constructor function. And when we would create the object, the values inside, like numeric fields, were automatically 0, right? And strings were null. And sometimes that's okay, and sometimes it's not. But that's what a constructor does, whatever it's supposed to do. If one is not defined, well, then we have a little bit of a problem. And that's kind of what these next slides are about. So with the rectangle one, if you remember, if we wanted to like fully create the object and give it its properties or its data, we would have to first declare it and call the constructor to build it, to set aside the spot memory and give it a name. Then we would set the name, and then we would assign the data for length and width, right? This one's being done through a method. These are being done directly with gets, or sets, actually, technically, right? We're setting the values. And these are, sort of implied in that, there's no method that we're assigning to. We're just calling that property and giving it a value directly. But really, there's a get and a set going on, and this is the set portion of it to set the information. So what if we want to build a rectangle and give it that name and everything up front, right? Well, there's a way that we can do that. And how we do that is we create a method inside of our class that is named the same as the class. So notice that the public class rectangle contains a public rectangle method, is what that is, right? But the names are identical. Exact syntax. We're talking upper, lowercase, and the whole bit. So I don't want to change it in any way, but the constructor method name is named identical to the class that contains it. So when we set up a constructor like this, we have to think a little bit in advance on how we're going to populate it. And wouldn't it be easier if when we create the object and call the new keyword to create it, that we just right off the bat send in a string with the name of the object, the length that we want, and the width that we want? It would be received by this constructor function here, and then it would pull the information into the same spots and then assign them to the data properties within the object. And I want you to look really carefully here about like some of the clever little tweaks that are happening. For example, since name in the constructor is the same name as the name in the data field, we are required to use the this keyword, or you could do the underscore method if you wish. I think that this method is probably more common. That's typical in most languages. Right. With length and width, those are coming in with lowercase letters. See that? But they're being applied to data properties with uppercase letters. And that's kind of a convention as well, right? Because these two names are different, I don't need to use the keyword this because they're different. So I think it's helpful to use names that make sense, but often I see programmers too, like maybe they'll just use the letter L or letter W, right? And this would be L and W, just to not even come close to taking a chance of putting in the wrong thing, if you see what I mean, right? Kind of eliminates the possibility of an error. But this is kind of the setup. So any constructor function that we would design that's custom is on us to decide what values we can throw at it to set. It might be all of them, but maybe the rectangle, okay, the rectangle is kind of a simple object, but maybe we're dealing with an object that maybe has 10 data fields, right? We don't need to necessarily set all of them, but we could set some of them. That's kind of the point here. So when we go to work with this, that's where it gets a little interesting. So the constructor is, pulling in, the name, the length, and the width. I want you to notice also, and this is a good point, there's no return type on this method, where all the other methods will have a return type. That's just required by the language, by the way. The class name must exactly match the method name or the constructor name. So those are, I think I already mentioned all those. Now, okay, so then that kind of begs the question. The first time we built this, we didn't have a constructor. So why were we able to even use this code? And well, the answer to that is because C# kicks in and provides a default constructor if one doesn't exist. And by its nature, it does not allow you to pass any values to it. So if you don't have a constructor inside the class that has values it's expecting to receive, then, and you're using the default, then you cannot pass anything. So in other words, I cannot put any values in the thing here, but I can, instantiate it in memory or create it in memory. Notice it says constructors without arguments are often called zero arg constructors or no arg constructors, right? Because we're not sending any arguments. Now, if you go through the process of actually creating this, right? So we add the code that we were looking at before. If I try to run the default constructor with no values inside of it, we get a secondary problem. This won't compile because now there is a constructor function and it's expecting values. So in order for us to actually use it, we have to tell it either if we want to use a no arg constructor, we would have to create another one inside the program or inside the class that would set default values. So it is possible that you create one inside the class that doesn't take arguments, but does preset a value to something. It's kind of an interesting thought, right? So I could call a constructor, not send it anything, and it can create something. And I mean, in this case, they're using name unknown length one with one, whatever. But, I would think that maybe it would be unknown and 0 and 0. It would seem to me to make more sense. But, the point is, if you have preset values you want to assign to something without any arguments, that's doable too. It's just a matter of conception more than anything. Now, if we are going to use the constructor now if we want to declare it, this is kind of interesting, right? We can declare a reference variable, but it doesn't create an object. So in other words, I can call it by its object type or class type and give it a name, but there is no object yet. It's not really in memory, right? We're just creating the reference variable that's going to point to it. Then we say the new command, and really, probably what would make sense to most of you is like if you were doing this, right? You would probably do it like this, right? So you would ignore this and you would just type this code here. So in other words, we call it like we did before, but now we're putting stuff in the parentheses. In the first spot, it's expecting a string. So it's going to be the name, and then the length and the width in that order. And because, these are doubles going in, we're feeding them in, excuse me, as doubles. Right, so it's kind of an interesting thought. So I'm going to Control Z that change. But it is also possible to do this. It's kind of like adding maybe too much information at once, but it's possible to declare, the name of something and still not have it created. But the moment we do the new thing, it calls the constructor function, we send it the values, and now it's created in memory, and we don't have to individually assign those things. They're already in the object. So this is a pretty powerful thing, right? It shortcuts a lot of code, and it's really commonly used. Now there's kind of this other little bonus thing that you can do here. So like, when you start to do this, it kind of creates a lot of questions, as you're kind of writing the code. And they have this alternative way basically that you can actually create an object as well. So you can actually, from the driver program where you're declaring this, you could, instead of putting parentheses here, I could take these and assign them inside a set of curly brackets following the declaration. So notice no semicolon here. We're just saying rectangle basement, new rectangle. It's going to trigger the constructor function, but it's sending in this information and applying it directly to the data fields. And then comes the semicolon, right? And so there are ways where you can kind of like hotwire it and do it different ways. I'm not a big fan of this approach, but I've seen a few people use it here and there. The interesting thing is, since methods, or in other words, the mutators, modify the data after initialize, they cannot be called within an object initializer. So in other words, this portion is set by a method, so I cannot put it up here. See what I mean? Because if you remember, we set up this method set name to protect the code inside. So the method has access to the data property, but the direct constructor does not in this case. Right? So like, in other words, the method is the only way to get that data in. However, the constructor can bypass that. But if you're using this approach and you want to set that string, well, you're kind of stuck with this, and that's maybe not what you want, right? So I would use this approach cautiously. This is the more common approach, and really, like I said before, with rectangle in the front of it, I normally wouldn't bother doing this. The only reason I would bother doing that is if I have a whole bunch of objects to create and I just want to remember not to forget it, but then I would probably add the new code after it with all the parameters thrown in to build it. Now, if you want, we could experiment with that a little bit. In fact, I did bring up the code from last time, and we could go right to the rectangle class here, and you'll notice how we have all the different methods that we created and all the different approaches that we tried last time. And and where we left it off was, using underscore name and underscore length, right? And we talked about all the reasons why we would do this. But we could create right here, and I would normally do this right after the data fields at the top. Right, so if you want a little practice here doing this, I'm going to bring the top of the class in just to remind me how I spelled it. Now, if you look at also kind of some of the approaches here on the slides, right? Like, other thing to remember, no return type, right? And we still have a set of curly brackets. The arguments or parameters in the order that we want to receive them. And often that will mimic what the data field properties are, by the way. So in this case, we would say public rectangle. And here come our parens. And notice how it's trying to help us out here. It is making a little bit of a mistake, isn't it? Are you guys catching that? Because it's trying to set length twice because I have a private and a public one. I am going to hit tab to accept it, but I'm going to tweak it. All right. So we got two of these. These are conflicting. And then after the fact, it realizes it made a mistake. So don't always trust the autofill. Now, we need to get rid of one of these. So that one's gone away. And now we're left with this. So when we call this, and we can experiment with this, and this is exactly what I'm going to do. We're going to send in a name, a length, and a width. So let's come up here and just give that a try, right? So we still have, the kitchen, the dining room, and the bedroom. And the kitchen, we already set all the properties manually, right? So we're going to leave that alone so we can still see that on the screen. But we didn't do it right here and for dining room or bedroom. And I want you to notice what's happening back in our driver program or like the main method here is now rectangle is underlining red. Now, if you recall from the slide, that's happening because the default constructor is no longer functional. And now these parentheses must have some information inside them. So really, truly, I can't do this here. So I'm going to get rid of this stuff, right? It's like, can't do it. So what we could do though, is we could instead apply that information up here. So we could say kitchen, and then what's our length? 10, I'm doing 10.0 because it's a double, and we use 14.0. That's also a double. And now notice the underline goes away. And since these two are going to get our compiler to fail, I'm just going to move my comment mark over here for a second to comment those out. And let's run the code and see if it reads that from kitchen correctly. So we're going to run it. And there it is. Of course, this 10 and 14 width and length, get the name, get the area, and the area property. We tried all the different approaches here, and it's all still working. But notice, how much easier that is than necessarily typing out all that code individually. Now, one thing you might think to yourself, it's like, okay, but wait a second. We have all these properties where we can set the name. Could I, after the fact, decide to call the kitchen and then call the set name method? And I'm not going to get the name at this point, but I'm going to let it create my stuff for me. But I could call the kitchen, I don't know, what joke were we making last week? The guest kitchen. My house is so big that I have a guest kitchen. And then, of course, if I want to output the name, then I could run it again. So what we should see is the same stuff we saw before, but now we'll see the guest kitchen instead. So let's run it and I'll show you what happens, right? So we can still change the properties after the fact using our methods or direct entry, right? So like if I wanted to change length and width, I could just say kitchen.width. Basically I could use the same syntax. It would still work. And if you're not trusting of that, try it. It's totally possible. But now that we have that constructor, it is expecting to see all three of those values. If we wanted to include, and I'm going to do this just as the sake of demonstration here, our own default constructor that accepted no arguments, we could set that up as well. So for example, and this is going to lead kind of nicely to this thought that we have later. We're going to talk about overloading methods. So I'm going to create another method with the same name. And this is really kind of bizarre because generally speaking, you think of that as a no-no. But with methods, I can have two methods of the same name. And if they have a different amount of parameters that are being fed into them, it's okay. So this is kind of weird. So let's go ahead and put in the curly brackets here. And what I could do is basically the same kind of thing we have here. I'm just doing this to not have to type so much, basically. So for the name, we could make it, you know, unknown, right? That would be acceptable. And with the length, we could preset it to 0 or 1 or 5, or if we had like a default amount, like if they don't declare the size of the room is 8 by 8. How about that? You know? So now with this change, now that I have a default one and the custom one where it's expecting the values, I could come up here and uncomment. So I could just move this comment mark down one line, and I could instantiate a dining room. And now notice it's not underlining red. And if I want to, I could just borrow, I guess, all of these and just switch it all to dining room, right? So make that. I'm just copy pasting it in. So let's run it now, and you'll see that the dining room picked up the defaults. 8, 8, unknown, and an area of 64. Kind of interesting, right? I don't know that I would use those values as default in this situation, but I'm just showing you that you can kind of manipulate it a little bit. If you do remove this and you only have this constructor, then it is expecting those values. But it is possible, and I know people have this question a lot. Well, if I do that, can I still have one that's blank? Yeah, you sure can. But then it better do something, right? So you're in control of that. And I kind of, like being in control of the objects in that regard. So you take that with a grain of salt, in terms of how you apply it. The situation will dictate when it's needed or not needed. All right, let's move on. All right, so we got all our constructor stuff done. Now we're going to start talking about the fact that we can actually do something really weird, which is to use objects as parameters or arguments. Now this kind of gets a little deep, right? Because we've learned how to write methods and functions where we can send an integer or a string or a Boolean or whatever, right? And those are simple data types, but it is also possible to take an entire object with all of its data and properties, whatever, and all of its behaviors, and pass it to something else. So as an argument or a parameter, either for a function or for another object or class. And the example that we have here in the slideshow kind of talks about that. So let's take a look at how this works. So when you're actually going to pass the object, right, and this is always kind of like a weird thing to really latch onto, is we're really passing the memory address. So we're like, hey, by the way, this thing is over here, is really what we're doing, right? So we're not actually like moving it out of memory and putting it in a different memory location. We're just creating a link to it, right? And this little, simple graphic tries to illustrate that. Now, let's take for a second into consideration that we could create a class called candle, right? And its only purpose is to basically tell us if it's lit or not lit, right? Well, we can also light it if we need to, and we can extinguish it if we want to. And then we have another method within there that we run to see if we can grab the private value is lit and let us know if it's lit or not, right? So you see the Boolean here is lit, it's true or false, right? So is the candle lit or not? True or false? It's one or the other. Makes sense for that, right? But that is a private. And so the only way we can see what its value is to write a method in the class that will check that private Boolean value and then return it to wherever it's called. So all the methods are public, The data is private, right? And so it's the candle class with three methods. Light lights it, is lit as true. Extinguish is lit as false. And then is shining just tells us which is it, lit or not. Okay. So now here's the example. And in this case, the public class birthday cake is not a class that's going to be used as a blueprint. It's just a regular program, right? And you can tell that because inside of it, there is a static void main that runs the program. That's the indicator, right? So when you have that inside of a program, that's what actually runs the code. So inside the main method, we are instantiating a new candle, right? Now, remember, candle has no constructor function, so it just builds in memory, right? So we now have a new candle. Then we call this weird function, I guess, called happy birthday, and we're passing to it the candle, right? So we take that whole candle object that we made, and now we're sending it to a function with all of its capabilities. It arrives here, right? And we're just using a generic C for candle, whatever. But notice the data type. It's not int or string or double, right? It's the object type, because really when we create classes like that, we are creating a unique data type is really what we're doing. So now whatever that object is, I can tell it to run its light method and it lights the candle. And then if I probe that object to see is candle or is shining, I think it was the method, it should say true, is shining true. That should be the return on that. But that's an example of how you do it. And then once you do it, this is kind of maybe the bigger takeaway here is not only can you move it around in a program like any other piece of information, but then because the object being received has capabilities, I can trigger those capabilities inside other parts of the program. So I can make it do the things it's supposed to do with a simplified syntax. But the whole point of this is that I could create any candle and send it in here and light it. Doesn't matter which one it is. I could have candle 1, candle 2, candle 10. In my case, it would be a whole lot of candles on that cake, right? You probably have to create an array of candles, or maybe I'd get smart and just get one of those, just has the numbers and call it a day. All right. So that's an example of how you would pass an entire object. Now, the point that they're making here is, that basically once you create the candle and you send it to the thing, I mean, it's the same thing. They're pointing to the same object in memory. So this code, even though I'm moving the object into this function, make it pass down here, and I'm saying c.light, right? The end result really is that C is really the same object as candle, right? It is candle, just with a different name on it, just for the moment. All right, so we're reaching this this try it together piece, and I think that what would be kind of good to do is that we work on this a little bit here together and see if we can create what we're doing or what it says here collectively, if you guys are with me. What I think would probably be wise is that we just create a brand new program for this rather than put it all, because we've been kind of taken, if you guys are coding along with me, that is, I don't know if you are, but this is kind of getting a little messy now, right? It's getting hard to follow because there's so much junk in it. The other thing that makes it a little hard to follow, real frankly, is the fact that, I did this as a point of example, is I put the class, we created a pet, and then we created a rectangle class, and I just put them all in the same file. And by the way, not the greatest of ideas, right? It doesn't make for clean code. So what we're going to do is let's go ahead and close this solution. So if you guys have been following along, that's what I would ask you to do. We're going to go ahead and create a new project, still a console app. Right, let's go ahead and click through, and we'll call this, oh, I don't know, mod 6 try it. Okay. We are checking the box because we want all the stuff in there, right? And then the other thing I'm going to do is I'm also going to create, by the way, an independent file that's going to be our class file, right? So this will be the program that runs it. And then let's come over here to the side. And we haven't done any of this kind of stuff yet here in Visual Studio. We've been focusing so much on writing code that we haven't really paid much attention to how Visual Studio operates as a product. But when you're in the Solution Explorer here, this is kind of an interesting tool because be sure you're understanding it really clearly that it's not actually a file manager, right? So it's not like bringing up File Explorer on your system or Finder on a Mac and you can see your files and it's all folders and stuff. That's not what this is. This is a hierarchy of the project components, technically, right? It could be files, and strangely, I could put files in here, right? But only if they're part of the project components. So what we're seeing here, the solution points to this, mod 6 thing that we've built. There is the program file that we are working with here, but now we want to add one. So what I'm going to do is I'm going to right click on the mod 6 try it part and then click on add, and I'm going to add a new item. Now that's one way to do it. And I'm going to do it this way, but then I want you to also notice that when you've done something a few times in Visual Studio using this menu, that it tends to add it down here. See this like section where it says class? It'll like, so if I add like other things, it'll kind of keep track of those and then put them up on the quick list so you don't have to look for it, by the way. So I'm going to, but for this moment, I'm going to add a new item and I'm just going to name it. And what is it that they wanted us to create? Create a program with a class named ingredient. Ingredient has 3 properties. All right. Okay, so that seems pretty clear to me. So let's do this. So let's create ingredient. Notice capital I. And then I'm just going to go ahead and click add. And now I have a separate file. And I want you to notice that it has, a bunch of different things here that we're kind of like working on. And look at all the using statements it adds up here at the top. Kind of interesting compared to this, which is inside of a namespace, and it's kind of it's structured differently, basically because of the mod 6 try it namespace. Now, what we're going to do is we're going to build our components into this file, and we have to think about those data fields that we're going to build. And the first thing that we're going to think about is, what did it ask us to do? Name, quantity, and measurement. All right, so let's get that going. So how are we going to do a name? That sounds like a string. And then we also have to think about this. Is this going to be private? Isn't going to be public? And how do we want to do it? I mean, so this is kind of a really quick question, but let's see what the ask is before we dig in here. It says, create a program with a class named ingredient. Ingredient has 3 properties. Create a 3 argument constructor. In the driver class, ask the user for 3 values, instantiate an ingredient object using the data, and print it out. All right, so that seems pretty straight ahead to me. The 3 things that we want to do our name, quantity, and measurement. What do you guys think for data types on these? String,
String for a
probably,
name.
right? Um, quantity,
Maybe an
integer.
integer.
Yeah. What about measurement?
Could
Given
do
the
a double for accurate. Maybe.
yeah, well, I mean, what they're saying is 2 teaspoons. So measurement is actually what, a string, right? Yeah, that would actually be a string. All right. So let's try doing this, and let's create. First of all, I'm going to blow away all the using statements. Why am I getting rid of the using statements? Because this program isn't going to need them. That's that's the why. The other thing is this is being designated as an internal class, and I really want to make it a public class. All right. Now let's put in the definition. So we're going to create a string, and let's stick with the question mark. Oh, I forgot the private or public. And we want to talk about this here a little bit. I think probably the smart way to do this is to create a private, right? Because that's considered the better convention. And what do we want to call it? What did they call it? Name. Okay, so let's stick with name. Name. Then let's just make all of them privates for now. And actually, we said the other one would be an int, right? And what was it? Quantity? Does that sound right? Yeah. Or should we make that a see, I'm like questioning myself here. I think I'm going to make it a double because here's the why, right? How many times have you ever cooked something, and is it always exactly like 2 teaspoons, or do you ever get one that's like 2.5 or 2.25? Right? Yeah. So I think it now I'm thinking a double makes more sense. So I kind of talked my way out of it, right? All right. And we have another string we have to create, right? So we're going to create private. What was it? Measurement, I think. Yeah, measurement, right? All right. So now we have another consideration to make here. And I want to jump back over without hitting that Zoom toolbar. All right. So I think we've accommodated for those 3 properties. Create a 3-argument constructor that accepts all 3 values. All right. That sounds pretty straight ahead. So we're going to create that as a public method, same name as the class, set of parentheses, and notice how beautifully it's picking up all the information. I'm going to go with it, by the way, and just hit the tab key there and just pull it all in and put in my parens. Now we need to apply all these, and it is auto suggesting, right? All right. Go with name and quantity and measurement. I think so. Those are all good. Notice that this keyword on all of those, right? Not using the underscore approach on this one. And this is the way I would normally do it, by the way, if you guys are wondering. Some of that is more comfort than anything else, right? That's just kind of the way I learned how to do it. So you tend to stick with the approaches that are comfortable for you, but it's one of many ways. All right. So first few tasks are done. So we've done it, right? So we done the first 3 bullets. Now in the driver class, so now we're going to go back to the main program. We're going to ask the user for three values, instantiate the object. All right, let's ask the user for the three values. That sounds a lot simpler right now, right? All right, so we're going to leave this alone. This is our class so far. We're just going to save it. There are no errors. We don't even need to compile it. It wouldn't do anything if we did, right? If I hit the run button, it would just look at the code and kind of go, okay, whatever, right? There's no errors. You're fine, right? It, in truth, when we compile the whole program, it does create this into a form of a binary, but it's not an executing one. All right. Now let's go back to the program, and now we're using, wow, 2 tabs, impressive. Let's put in a prompt. And what are we asking for first? Okay, we're asking for the ingredient. Enter, or should I just say ingredient? I mean, I think that was the implication on the slide, ingredient. Right? What comes next? Do we need a variable to put it in? Interesting. I would say yes. I think we need a variable here, right? Because we're bringing in stuff from the keyboard, right? I think we need a variable because we're going to have to send it in, and we're going to need to make that adjustment. So let's go ahead and do the, and the first one's going to be a string, right? And what's a good name for it? Maybe ingredient? What do you guys think? Okay. All right. We want to read it in from the console. Is this okay? Do I need any conversions here? It should be okay, right? All right. Let's do another prompt then. And this time, let's say write. And I think it's quantity is next, right? I'll check myself, right? Quantity. And then we're going to need, well, oh wait, this can't be an integer. It has to be a double, right? And could we abbreviate, or should we abbreviate? Could we do this? You guys comfortable with that? Okay. And then, of course, we'll do our console read line. But this needs a conversion, doesn't it? So could I do this? What do you guys think? Right. This should be feeling a lot less intense than it used to feel, right? Like when we used to do this at first, it was like, oh my God, how do you do this? And now it's like, oh, this is the easy part. Right. And now we have to kind of repeat again. So I'm going to just do a little time savings here and just, and what is it? Measurement. And this time, let's call it measure for good measure. Why are these? Yeah, they want us to put the question mark in. I guess we should be nice and do it. Okay. There's our prompts, cleared the variables, and did it all like that. Now, if you guys are in the habit of, like, when you're writing your code to put all the variables at the top, that works too, right? So you could do that. You can pre-declare them. I'm more in the habit, and I'm not sure if it's like kind of the after effect of like Python, I think a little bit, right? Because I've been coding a lot of Python the last few years, where you just kind of declare the variable when you need it. You don't worry about declaring it at the top. Probably not the greatest idea always. Now we have to, so we did the prompting, right? Ask the user for the three values. Okay, did it. All right, instantiate an ingredient object using the data. Let's try doing that. So we're going to call ingredient. Now notice, because it's in the same project, in the same resources, it just finds it. Isn't this cool? So I can just call it in by name. It's basically a custom data type, and we need a name. I don't know. What are we going to call it? I'm not really sure what to call it. Somebody give me a brilliant idea. I'd say recipe, but that doesn't really make sense, right? How about recipe? Really, it's it's an ingredient. Could I, you know what? I use the name ingredient here, so I probably should have. How about our ingredient? Just to make it unique. You could come up with something more clever. I'm just like, let's just say that. Like, I'm not coming up with these names as fast as I probably should. And then we want to trigger ingredient. And is it expecting an empty constructor or constructor with stuff inside? Well, if I leave it empty, it right away is giving me an error, but I did that on purpose, right? Because I love the fact that it can go into the other file, read it, and tell me what I'm supposed to drop in. It's expecting a string, a double, and a string. Okay, so let's give that exactly what it's asking for. So I guess we could just stick with basics, right? Salt. Let's go with 2.5 to make it a real double. And what? Teaspoons, tablespoons, cups, gallons, bushels. Yeah, no, now I'm really getting silly. All right, let's just go with teaspoons, kind of like the example. So that would instantiate the object. All right, what's the next thing? Right. Print out the ingredient. Okay, I think we can do that. All right, so now how would we go about printing it out? Now, what we kind of saw in some of our examples, is we reach into the object and we just right line each individual part of it, right? We could do that. You could also create a method, by the way, that would do it. That would be part of the driver program. Or, and I'll just kind of put it out there as an idea, you could actually say print, you could create a print method or print ingredient method inside the object itself, and then you just call the object and tell it to put it on the screen. That's kind of an interesting approach. I'm going to do it the first way though, but I just want you guys to think about that. That's a possibility, right? Like so if that's something that would happen commonly, you would just do it, right? All right, let's do some console write lines here. And what are we right lining? See if we can do this. Well, we're going to right line the name, the quantity, and the measurement. All right, so you guys realize we're going to run into a little bit of a problem here, right? All right, let's try this, and then you'll see what I mean. Does anybody know what problem I'm going to run into and why before I even go to the trouble of doing it? Oh, I'm doing this in the wrong spot. I apologize. No wonder it was underlining red.
Did you forget a
So what am I trying to
semicolon?
output? Say it. Somebody say that.
Did you forget a semicolon?
Oh, I did. Yeah, I absolutely did. No, but there's kind of a all right. So we created an ingredient called our ingredient, and we want to pull back its name, right? So let's just say I want to do this. Why is that underlining red? Yeah. Read the error message really carefully. It says class string represents blah 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 blah. CSO 122 ingredient.name is inaccessible due to its protection level. So it is what? What is it? It's a property, but it's a private property, so we cannot access it. So what it's trying to do is reach into the object and then pull back this information, but it's private. So what are we going to have to obligatorily do here is we're going to have to create a method. So we would create a public string. We're going to return a string. And let's call it get name. Right? Are we needing to put anything inside of that? No. All we're going to do is return the private data field that's not accessible directly from the outside world. So we're going to return name. That's it. And you know what? We're going to have to do the same thing a few times over. So we're going to do it with each one of those. So we're going to do a double get quantity. See how it's like figuring out what I'm doing. So I'm just letting it do it. Right? I'm not typing most of this. Get measurement. Yep. And why does it not autofill that one? Thanks very much. Right. And what's that? What do we call that one? Measurement. So there you go, folks. So what we've done now is we've set up 3 methods in the class that will get the name, get the quantity, and get the measurement. Why are we doing it like this? Because the data fields are private, and this protects them from being changed and the data being polluted. That's the why, right? Now notice this is not saved, so I'm doing a Control S to save. Now we'll go back to the program, and now it's still red. Well, of course, yeah, because we're still trying to call the property directly. What we really need to call here is get name, right? And then, you know, if you want to follow the stream here, we're just going to copy these. And then for this one, oh, but I forgot my parentheses. My bad. All right. So we're going to get name. We're going to get, is it quantity? Yeah. Quantity. Parens. Don't forget those parens. And then get. See, I go back to the dot because I know it will trigger the autocomplete. And after a while, you get used to it and you kind of lean on it a little bit, by the way. All right, so there we go. Now we can pull the 3 things back. I'm going to save this and I'm going to run it. So here we go. Here's my prompt. So let's put in salt 2.5. Okay, so we created the object. We set up the data fields. We set up 3 methods to pull the data back. We also set up a constructor function to set the data. And then we use an external program file to reach in, you know, and create it and run it and make it all go. The one thing that is kind of important here and was a little weird at first, right, is we had all that extra stuff in here, the using statements. It said internal class instead of public class, but with just little tweaks, and it's okay. Now, one of the reasons the program CS file can find the ingredient CS file is because they are in the same namespace, you know, as indicated here. Right, so they're kind of part of the structure. So like, once again, it's not a file and folder structure, it's a symbolic structure more than anything. All right, so that's kind of an example, and this is going to kind of lead us into our lab for tonight, by the way. Also, it's very, very similar. But that was a really nice little try it, I think, where we kind of practice some of the skills more practically. We could put in some of the same stipulations. So if you thought about like the rooms and how, what if somebody put in a negative length or a negative width? I mean, they could do the same thing with like quantity, right? I mean, quantity could be, somebody could get snarky and say, well, put in -2 teaspoons, you know, and that would not be disallowed under the setup. However, we have had an example of how you might write the code. If you guys remember looking at that other program where we set it up so that if it's greater than 0, then we assign the value if not, right? So you can write code to do all that stuff. Right. This is just a really simplistic example. Any questions or issues with this, you guys? Anybody try it with me? Okay. I think what would be good at this point is let's take a break. We've been going for a solid hour, and let's do like a 5-6 minute break. So I'll see you guys at about 8:05 or 8:06. Pausing the recording. All right, we're back from break, and we're gonna now talk about overloading. Even though we've kind of done this a little bit already tonight, but now we'll learn about it formally and with a twist, right? A couple twists actually. So this concept that we can take methods within a class and overload them, meaning actually have more than one method in the same class that has the same name. And in this case, in this example, it's accepting two different types of parameters. If both of them, add, if you will, if you look at the code real carefully, the first one takes two integers and adds them together and returns the sum, while the second one takes two strings, concatenates them together, and returns the result, right? But they both have the same name. All right, this is kind of a weird thought for overloading. So when I'm calling that method, and this would happen externally, and I send in add 5, 5, and 5, the engine inside of C# has to basically check that out and going, oh yeah, I found add, but wait, there's two of them. Which one should it go to? And that process of figuring it out is called binding, right? So it'll bind. So in this case, the 5 and the 5 would bind to the first version shown here, which accepts integers, right? So that it would bind to that automatically. C# handles that for you. Right? And kind of an interesting thought here, when we look at how the stuff is put together, this add as an int and an int, and add as a string and a string, that is considered the signature for the method. The combination of the name and the data type it's accepting. And that's how C# or the engine of C# will figure out where to send it and how to process it. Now, I think what's kind of interesting in these examples is they used a method with the same name with two different types of parameters being sent into it, numbers and letters. Interestingly, though, you can also use it to send in a different quantity of parameters. So if I had an add that had a, like, let's say accepts 2 ints, and then I had an add that accepted 3 and another one that accepted 4, I could include those two. It's just how many values I'm sending to it. And so when we say we're overloading a method, you have to actually set it up so it can do that. And it's a clever programming thing, basically, to allow that to happen. Now, this slide here kind of makes the point, when we're working with, methods that are inside of a class, things that aren't included as part of the signature. So in other words, going back to this idea, see the underlined items, add with an int is like kind of like its footprint, so to speak, and add string is the second one's footprint. What isn't really part of that signature, it doesn't care if it's private, it doesn't care if it's got a return type, and it doesn't care what the variable names are. That's not what it's looking at. And that's more informational than anything else, honestly. Constructors, as it says here, can be overloaded. So we did this already, right? And I kind of gave you maybe a sneak preview of slides down the road. And so we set up a constructor that accepted the values that we wanted, just like, the room, the length, and the width. And then you can also set one up where, now that one's kind of different from what we did, because the one that we did, we set like a length and width of 4, right? This one's just setting the name. Would that one work? Yeah, it would work. And here's why, because the numeric private data fields would automatically initialize to 0. That's why. So this would be an acceptable constructor also. But it's very common to have overloaded constructors, especially in the situation of like, you want the object to be created, you're not really sure what you're feeding to it yet. So, but you're setting it up so it can, right? But you're putting in some default values so it doesn't crash your program or whatever the situation is. But that's one that we've already tried, and you saw kind of the combination. So I think that that's a really clever thing to do, is to set up constructors like that, so that if somebody just calls it, it gets created and doesn't crash. Or if they know what parameters to send in, you send them in. All right, so then the question pops up, why do you even bother to do this? And really, the thinking is it generally makes all the classes much more flexible and versatile and capable of doing so much more. And really, I guess, set it up so that it's just more possible to be flexible coming in. Like, so like if you send, like with the add example, if I set up like, I don't know, 10 add methods that accepted different numbers of integers, I'm just like hedging my bets. Basically, I'm setting myself up so that it would work no matter how many parameters somebody throws in there. That's probably not an ideal situation, but it's possible, right? And that way, if they send in 2 values or 3 values or 10 values, it's all set to go, right? Just more versatile. Now they give this consideration of a bank account class with a deposit and withdrawal method. Okay, so why would you consider an overload in those situations? Well, maybe there is no withdrawal, or maybe the withdrawals of a certain amount, So depending on how many things you're throwing in there, we can adjust to it, basically, is the way I'm thinking about it. One pair that takes strings, one that takes doubles. Okay. And then you keep the type conversion logic internal, right? So that, and the whole concept of this is really that black box effect. Like, people don't know what's going on inside your code or your object, but it doesn't matter because it works. That's really kind of the big takeaway. All right, so now they're asking us to try another little task here. So let's do this. It says modify the ingredient program to include an overloaded default constructor. All right. And, I kind of think we already did that, but let's go ahead and create another one here. This is good practice, by the way. And this time we'll leave it empty. And what things do we want to set here just in case? Well, ideally we would set all of them. So we could say this dot name equals, well, it could be null, right? But that's what would happen automatically. But how about, let's go with the unknown thing. That's kind of a good one. Right. Quantity would set to 0, and it picked up my pattern, right? So I'm just going with it, unknown. So if they don't send something in, then it's going to be unknown and there's no quantity. Right. Back in the main program, I'm going to save this, by the way. We could instantiate another object. Your ingredient. Same syntax. This time we'll leave it empty, which it doesn't mind. And then we can take these right lines here, repeat them, and just add a Y to each one. prove that it works. Let's go ahead and run this. Of course, we're being prompted for it, but that's for the other one. So last time we used salt, this time we'll use sugar. Lots of sugar. So let's say tablespoon, 8 tablespoons. So it did pick up the stuff I typed in. Or did it? You guys never caught me on this, did you? We made a mistake in our original program, so I feel kind of silly now that I look at it. But these really should have been variable names here, right? Yeah, nobody caught it except me the second time through. So ingredient, what do we call it? QTY and measure. Right, that's what we should have done. Of course, the output will still be the same, right? But the point is, we captured it. Why do we capture it from the keyboard if we're not using it? That's kind of the point. Right, so now let's try it, and just to make sure, let's try sugar. All right, sugar, 22 teaspoons. And then the other one that we created with the default constructor, which just set it to unknown, 0, and unknown, seemed to have worked just fine. Yeah, but I'm surprised we missed that, actually. Go to the trouble of prompting them, and then we hard-coded the values. That was a mistake, big time. All right. I don't know if you guys are trying this. You guys are getting it to work, hopefully. Let's go back to the slideshow. Finally into the last section of the slideshow. So we got a little bit left to do here. Now, we've learned a little bit about like arrays and lists and stacks and collections, as we call them, collections of information. And then you start to realize that objects are kind of that too, right? They're kind of a collection of information unto themselves. And what becomes really kind of interesting is that we can actually use the objects that we create to create custom collection types, right? So we're, kind of creating a collection of objects, if you will, and placing them in a complex structure called list. So you can take those objects that you create and drop them in here by name. So we're creating a list. What kind of data is the list going to hold? Rectangle data, right? Kind of an interesting thought. We name it boxes. We call the constructor. Look at the syntax on the constructor because it's a collection. Those angle brackets with the data type exist here. This would call the default constructor, of course. From there, we would create, in the first example, a rectangle called a shoebox, and it's a new rectangle with some data thrown in. And then we're using the add command, which adds or appends to the end of the boxes list another object of type rectangle. So that's one approach. So you can create it in one line and then add it to the list, or you can create it and add it to the list all at once. And this is kind of, an experienced programmer shortcut, really, right? So what are you adding to the list? Well, I'm going to instantiate a new rectangle. So I'm still sending in all the information. I'm just not going through the process here of naming it. So this one is getting added to the list, but without a name. Or does it have a name? It does, right? So its name is internalized. That's its private data field that gives it a name. Here's its private data field that gives it a name. Right? I don't need to name the spot in the list that it's going to. The name carries with it. You see the difference, right? Yeah, that's kind of a neat little thing. But this is a nice little shortcut approach to it. That you can instantiate an object and then put it wherever you need to put it right away. Saves a line of code. Now, once you've gone through the trouble of creating that, you can use all the capabilities that are available to a list. Well, we already saw the fact that we use the add, function to add another object, but you can also use like for each to iterate over that custom collection and extract the information. So if I have a list that contains a bunch of what were we working with, boxes, right? I can run the for each command, indicate the data type once again, box and boxes of data type rectangle, and I can output it. I can reach into each box, right? So this is a localized variable here. So any of the objects will be passed as parameters into this spot, right? Box, and then it triggers the internal get name, and then whatever other stuff you want to put on the screen. This is all done with string interpolation, but it's a nice quick little way to be able to take a whole bunch of objects, put them into a collection or a list, if you will, and then output all of them at once. A lot more efficient, right? And actually a very common type of action, really, in programming, what we're seeing here. There's a couple different ways, of course, that we can actually initialize a list, and kind of like we saw with some of the other constructors that we were looking at before. In this case, we can also set up a new list using this type of approach. And notice the var keyword here. Oops, didn't mean to move that. Just trying to highlight var. And then kind of that same approach with the curly brackets. So there's no parens here to call the constructor. We are instead doing a direct instantiation of the object into the list. This is a little bit deeper than what we just did before as an example, but this is possible because that list holds data of type rectangle, a custom data type. We can therefore directly instantiate into that list. So if I had 20 objects to create, this would be an efficient way to do it. And then curly brackets, notice the semicolon at the end, and then I could still iterate over it and it should output it. All right, let's move on to the next slide. So it says here, if you're reading data from the user, you can create your object first and use the setters as you read the data. So for example, we make a rectangle, we add the rectangle. Notice this is a default one, nothing's included, right? No data. So we can add it to the list, right? And then we can prompt the user for the data. So for example, enter the name of the box, we can read it in, and then we can directly do a set line command. This is kind of interesting. So instead of feeding it into a variable like we've been doing, you can instead take that information and directly pump it into that data field using the method in the class. And you would just call set name. It would read the read line and just send it right into the object. Of course, if it's a number, we still have to convert. So that one doesn't work quite the same way. But we can directly assign it to the property. So I think that's kind of neat. So even though the rectangle, the point of this really is, even though we created this rectangle object and we put it into a list of rectangle objects, I can still access each one individually and manipulate all of its properties and use its methods. The list just becomes kind of a convenient way to store it all together. That's what it is. So this is a nice little example. Of course, if you wanted, you could copy this code and try it out. I'm not going to do that, by the way. Now, the other interesting thing here is it says if you're reading data from the user, you can use local variables to read the data, then make an object with them once you're finished. Now, this is the approach we already used with the ingredients, and I failed to use the variable names, right? You guys caught that, but that's okay, right? It kind of reinforces the point. So that's a really, really common technique too. So you prompt, you capture and store in a variable, right? Prompt, store, then create the object, feed in the variables that you captured, and then you can add it to the list if you wish. So that's another way to do it. All right, so now they're asking us to do a couple more triads. So we're going to do these, and then we'll switch over to doing the lab stuff. Okay. It says modify the driver class to include a list ingredient object. Add ingredient objects to the list and loop until NA is entered. Okay, so now they're at, now it's kind of a tall ask. They're asking for a lot of stuff here. You know, so let's see if we can kind of put this together. What's not a bad idea, like if you struggle with the syntax, you can just look at the examples, right? You can just copy that in, but we're going to basically do this. And I'm going to go ahead and type that in. That's going to go in the program file. And I'm going to put that up near the top because to me, that's the spot that makes the most sense. Yeah, I didn't want an int, but I did want the autocomplete. So we're going to put in of type rectangle. This needs to be fixed. So there's our empty list. And now that we have these, now we have a lot of work to do here to make this work exactly the way we're being asked. But we do know that all the code that we have here works. So what I'm going to do with this, I'm just going to basically do a comment on it. So I'm just going to do the quick CSS style here. And then we might pull some of that in, but we're just going to use that as kind of a guide. So, all right. Where was our instructions? Okay, modify it to include a list ingredient object. And I put in rectangle. Okay. Epic fail once again. So there's our ingredient list. Add ingredient objects to the list and loop until NA is entered. So could we use the prompts that we had before to do this? Okay. Does it sound like a while loop to you guys? And what is the syntax that's going to get this to run? Well, whenever they type NA for ingredient, that's when it will stop. So you know what? I'm going to have to pre-create a string called ingredient. We'll leave it blank, right? Or should we leave it blank? Or could we, and maybe it's better to do this. So I'm trying to get you guys to think here. What condition are we going to be checking to run the while loop or to end the while loop? All right. So we are looking for the ingredient to not equal NA. Correct? Right? Because the moment they enter NA, we want to stop all the prompting. Now I could and should be able to take these prompts and put them inside here. Of course, I probably want to do a little bit of work because this is now not making sense, right? I don't want to redeclare this variable. I just want to assign it. This one probably should be pre-declared. So let's just put it up here. And let's just set it to 0. And then we can get rid of this declaration. And then measure should be pre-declared also. and we can get rid of that declaration. Right, so while ingredient does not equal NA, does ingredient equal NA here? No, right? So this should execute and then ask us to input these things. Now, what's going to happen after we input those things? Here comes the part with the object. All right, so now we need to take the data that they just entered and create a new ingredient. And then add it to the list, right? So could I do this approach, the one I highlighted, where I'm declaring an ingredient, data type, I give it a name, I say new ingredient, I feed in the variable. Sure, I could do that. But then I'm in a loop, and this loop's going to run over and over again, and the name's going to change. You guys see the problem with that, right? The name's going to change. So I can't really do it that way. So what I really need to do is put it right into the list, add, and see how it's picking up on that very automatically. I'm just letting it do it, right? I'm just going with it. So after we've read that in, it's now going to directly add that new ingredient directly into the list of ingredients. Boy, we keep doing this, we're going to have a whole recipe pretty soon, right? All the ingredients for a recipe. Yeah. All right, so we can keep typing it in. Now, here's kind of a weird question. So when we learned about like while loops and user prompts and all that, will this work okay? Do I need to prompt before we go into the loop, or will this work? Well, some might argue, and I'm putting it out there, you guys, that we would want to maybe take all of these actions and put them outside the loop and do what we call a priming read of information. Now, because I'm already presetting ingredient, and right now it's an empty string, but it's still something, it would work. But that might be a consideration. The other consideration you can make is instead of a while loop, you could do a do while loop. So it would do the one run for sure, and then give a person a chance to type NA. But in this case, they have to go through the process. We're going to leave it alone for now. These are just things to think about when you're writing programs. Do you want to do that? Do you not want to do that? And then ultimately what happens is you try it to see how it goes. And then you go, oh, wait, that didn't work so well. Let me try it the other way. Right. So we might do a little bit of that. Right. So we've gathered the information, we've prompted and created the objects. And now let's move on. Right. So we're going to add stuff until NA is entered. Okay. Well, and that's it. We're not going to look at the output. Now, when the user is done entering ingredients, print them out by looping over the list object, kind of like the example that we had before. So let's see if we can concoct that code real quick. So we'll do a for each. And then here comes the syntax. What's the syntax here? Well, what's our object data type? Ingredient. And then we need a kind of an internal variable name here. Let's just call it, I'm just going to call it ing. Maybe that's not good. How about item? Now, see, I don't like that. So I'm struggling for a name here, right? So ingredient in list, right? So list doesn't really make sense. I should have probably called this something different. Can we think of a better name here? I have an idea. How about ingredients? And then if I'm doing that there, right, then that needs to be updated here. So if you guys are following along, right, make that tweak really quick. So all right, I'm going to kind of break one of my cardinal rules. and do this, right? So this is kind of the singular and plural. It really doesn't want me to do it. All right, so how about we just go with like, I'm just gonna call it that, just, just to kind of get it going here. All right, and now we have to do our looping, and all we're really gonna do is output, right? So we should be able to just do a console dot write line. And now we have to start thinking about how we're gonna put this together. So first things first, I think I'm gonna use string interpolation because I think that just makes a whole lot of sense to do that in this situation. And then we need to read from each position in that list, the ingredient name, the quantity, and the measure using the syntax from this file. So name, quantity, and measurement. So we're going to say INGR, which is my short way of saying ingredient, is whatever the current object is that we're looking at. And then the first thing we're going to look at is name, right? Right. Let's see how I'm verifying. I'm just going to type name. Oh, I forgot my curly. Sorry about that. I'll do that. And then we'll do ingredient. Let's see, now it's starting to pull in the stuff. And all right, well, name is not accessible, right? So here I am making the same mistake. I want to use get name for the name because that one's protected. Here, I want to say what? What was the second thing was get quantity, right? And finally, get measurement. All right. So it's just going to say salt 2 tablespoons or whatever. That's how it should read. And then that's repetitive, and it's going to do it for each time that we enter an ingredient. All our other stuff is still down here. So here you go, folks. That's the whole driver program. I am saving it. I'm going to go ahead and run this. Let's try this. And that way you guys can still see the code, right? And so let's do salt 2 teaspoons, sugar 4 cups, flour 1 cup, milk 0.5, and really I should say cups, right? So yeah, I screwed up on one of them. What other ingredients? Egg. This is a hard one, right? This is not set up really well for eggs, is it? Because you would just say ingredient, egg, quantity 2, measure, eggs. That one makes no sense. Sorry. I should have picked better. And now I'm here and I want to get out of here. So I am going to type NA. I really should include in the prompt, type NA to get out, but I didn't do that. But you can fix that, right? So hopefully that takes me out. Okay, now you guys are starting to see my logic flaw. Okay. Yeah, and it crashed. So we'll talk about here why it crashed. It's the so I typed NA here and it read it in. How could I break out of that loop? Is there a way I could break out of that loop? I mean, is there a better way to do this? Like, where should the prompt be? This is kind of the key logic here that we need to figure out. You guys feeling where I'm going with this? Because obviously this didn't work. Now, whether it added the ingredient, the quantity, and the measure to the object, we really don't even know because we didn't give a chance to look. Right? Could I, suggest that we could comment out the whole loop, run this code once and see if it even works and outputs correctly? We could do that. Or do we really truly need to have the priming read happen up here? All right, so this is the logic leap, you guys. So I'm just going to kind of go ahead and start doing this. I am going to do a priming read. So I'm cutting it. I don't want to cut it. I just want to copy it. And I want to put it up here. So we'll let them do this the first time. Provided that logic is okay, then the first thing in the while loop would be to add it to the list. Right? Then they get prompted again and add more stuff in here. But if they enter NA, that will never get added to the list. Will they still get prompted? Yeah, they will. Okay, so that creates a second problem. Here's the second problem. We can write a little bit of code here. If ingredient got my parens. If ingredient does not equal NA, let's see if you guys follow my thinking on this. Then we'll prompt him for this stuff. What do you think? You think this will work? Or you might not be seeing it immediately. So up here, and of course the proof is in testing, right? So we have this written. They get prompted, we store it, prompt, store. As long as they didn't type NA up here, the loop will operate and then add this item to the list. The first thing that will happen is it will add it to the list. Then they'll get prompted. And as long as they didn't type NA, get prompted again, get prompted again. They didn't type NA, so it goes back and it adds it to the list. See the thinking here, right? Kind of a little backwards from what you might have thought. If we do add something to the list and then they type NA, then they won't get prompted for the other two items. It'll just skip right over it and then we'll pop out of the loop. So to me, that's effective code. Let's see if that works. So, before we worry about the output, we'll see if this works. Save and run. So salt 2. I'm going to start abbreviating because I'm doing it too much. It did pop me out of there. But now there seems to be a problem with how we're console right-lining this. So what does my error message say here? System func string sync double sync func. Yeah, okay. So a bunch of gobbledygook that I'm not really sure what it means. So apparently my output is not correct. All right, here's what we'll do. Let's take a look at the example from the slide. And what did they do to make the output? They did that a few slides back. I think we just, oh, there it is. Right. Oh yeah, see, did I put my parens in there? Yeah, I didn't. That's what system function means. This is a function, it's not a property, and you're calling it, and it's not working. So see how easy that is to overlook? Right, because back here, get name, get quantity, get measurement. They're all functions or methods with parentheses. So here we have to use the parentheses. So now I think we're okay. Let's save and run. So there we go, folks. We're able to build the objects, put them in the list, store the stuff, add values to it, and iterate through it and put it back up on the screen. Pretty nifty. All right. Now that we're done with that, I'd like to get into the lab, but before we start, could we take a quick 3-minute break? Give everybody just a quick pause from this. And if you need to go to the bathroom or anything like that, it's a good opportunity. And remember, this will all be in the recording, so you can always go back and refer to it. I'm going to pause the recording and I'll see you in a few minutes. Okay, we're back from break. And we are going to start working on this module 6 lab. And as I was just prefacing everybody, this is very, very similar to what we were just doing during the PowerPoint with the try it thing. And we are going to ramp it up though, and we're going to like tweak things and alter things a little bit. I'm going to show you kind of like a little bit different approach to kind of accomplishing this, because for the most part, it's doing what we already have planned, right? We're going to prompt our user, we're going to get information, we're going to store it in a list of ingredients, and then we're going to output that list. There's one other additional wrinkle here, though, that's kind of interesting, and that is that we're going to basically add a recipe layer to this. So this is where it gets kind of interesting. It says modify the try it program from my module 6 slide deck to also have a recipe name, which is a string. Okay, piece of cake, right? The user should be able to enter one recipe with multiple ingredients. Okay, we got that piece figured out already. When the user is done, the program should print out all data collected about the single recipe. And after your program runs, it should kind of look like this. Now, here's the kind of conceptually, because it is possible to do this without really changing the code that we have much. So if you think about this, you can just put in a little prompt that asks this, right? You capture it, then you do all the code we already have, right? We know how to do that. And we also know how to do the output. But when we do the output, we would just have to add one more thing. So that would be one way to do it. And you know what? I wouldn't really have to write a lot of additional code. I would just write, one prompt to say, hey, enter the recipe name. I would save it, right? And then I would just output it and I would be done. And frankly, for those of you that may have done the exercise already and did it that way, that would be absolutely fine. And if you want, I could, kind of quickly demonstrate that. We could just simply add a couple of things. So I'm just going to do this really quickly, and then I'm going to alter it, by the way. So I'm just going to call it recipe name. We'll start with it blank, and then we'll give it a semicolon here. And then we'll just do a really quick prompt. We'll ask for recipe. Store it in recipe name. And then we'll just do the other stuff like we normally do. And then when we get down here, we'll just have before we do the for each loop, we'll just have a little console write line. And then we can just very simply output the recipe name, right? Just fumbling with my keyboard here a little bit. And that would really kind of be about it. That would do it. In fact, let's run it and just try it. And I'm just showing you that, like, if you did it like this, I would be perfectly fine with it because it really does accomplish all the goals of the assignment. But I could just call it, you know, and then, you know, the same kind of routine. Um, and then I'm just going to end it really quick just so you can see. So it would output chocolate chip cookies and then the ingredients. And if there was a list of ingredients, it would output all of them, right? So that would be pretty cool, right? I mean, it's kind of like a real recipe. All right, well, that would be one approach. So I'm just kind of putting it up on screen right now. So there it is, problem solved, lab is done. Right? That was almost way too easy. But I want to show you a different kind of thought process on this. To kind of get you ready for like kind of like a deeper level of this, right? So if you maybe thought about this and go, yeah, that's exactly how I would fix that and complete that exercise. And that works. It absolutely works. However, when we're dealing with this concept of a recipe, we can do so much more with it. In fact, you know, we're already dealing with a list of ingredients and then creating this thing called a recipe. And the recipe, I want you to think about this really carefully. We created a list of ingredients, and a recipe includes a list of ingredients. You guys kind of catching where I'm going with this? So the listing of ingredients is part of a recipe, but it's not the only part of a recipe. There's another part of a recipe. What's the other part of a recipe? And that would be basically the instructions for how to do things, right? So anybody who cooks, usually you look at a recipe, it's got a name, it's got the list of ingredients, and then it has a set of instructions on how to complete the recipe and execute it. Maybe even how to serve it, you know, all that stuff is built in. So really a recipe contains a list of strings or a list of ingredients, and it has a name. And I don't know if you guys are catching where I'm going with this, but it begs another list structure, and really it begs another, honestly, class structure here. So I'm going to modify this program to include an additional class, which is going to be recipe, which is going to contain a list of ingredients. And then I'm going to rewrite the main program to kind of flow with it. And you guys will see where I'm going with this. It shouldn't take too long. So let's plow into it really quick. I'm going to add another class file. C# class is fine, add. All right, I'm going to get rid of the using statements like I did last time. I'm going to change this to, oh, you know, I totally blew it on this because it, rename it. And I want to call this recipe. It will automatically change it. And it didn't even squawk at me about forgetting to finish that part. So we have a public class recipe. Now what I'm going to create here, and I'm going to do this pretty quickly. Just remember, if you're not keeping up, because I'm going to start copy pasting a little bit just for speed, is you can always go back to the video and watch the video to catch the details if you need to. All right. But what I'm doing here now is I'm thinking of a recipe on a higher level. And really, and I want you guys to think about this, what I'm about to say is we're abstracting it as an object, right? And thinking about what that object contains to kind of deepen this object concept. So recipe contains a list of ingredients, and it also has a name. Those would be its two data fields. Now, so it's kind of thinking, okay, you need a description for your recipe too. I am going to put in a constructor. So let's put in a public recipe. So the curly's here. What would I feed into this? Well, think about this. When we prompt the user, we're asking them for the recipe name, right? I would send in a string. So I'm going to put in a string. It'll be name. And of course, then we will assign it to this name. Another thing will happen though, and here's another conceptual leap. Every time we create a new recipe, we also are creating a new list of ingredients. So think about this. I'm going to, oops. I like the auto type so much better. All right, let's try that again. Let it instantiate the list. So what we're doing here is we created in this spot the capability of holding a list. Here we're actually instantiating, right? And placing something into it, basically. So we're making it and putting it into this list. All right. That's the first thing. Now there's a bunch of different things that we can do here, and I'm just going to kind of do this in kind of a rapid fashion. So I hope you guys can hang with me here on this. First, I assume at some point we're going to output the name of the recipe. So it's really logical to create a method that does that. So let's do a get name since it's a private, right? There's that thing. The other thing is, conceive this now, that because I'm handling the list of ingredients inside the recipe class, I need a way to add the ingredients to it. It is a list. So I'm going to make this method that allows me to add an ingredient directly to the object in the list inside of my recipe. Does the order of these methods matter? Frankly, no, it does not. The convention is data fields at the top, constructor next, and then all the other stuff in whatever order you deem necessary. All right. The other thing I'm going to do, and this is in order to kind of shortcut time, if you guys are trying to do this approach, I'm going to drop the next bit of code in the chat because it's a little bit like so far you are probably keeping up, right? Not too hard because I'm talking a lot also. But this next part, here it is. I hope it fits in the chat. I think it did. So if you want to grab that code, you can just drop it right in. I don't often give a gift like that to the students, by the way, right? But I'm copy pasting so you guys can copy paste a little bit too. But I'm going to drop in this little bit of code here that's going to allow me to pull in the information. So I do have some red underlines here, and that's because my names are not jiving with the ingredient file because I changed the code from my example to this. So I will have to fix these function calls. But here it says get quantity. And what is my function name for my ingredient thing? So you guys have to change the same code. We are gonna get, see, I need mine with a lowercase g with parentheses. And then get measurement, I think is just lowercase. And get description was the name. So what we're doing here is we're kind of flipping the order as well. So in other words, instead of saying salt 2 teaspoons, we're going to say 2 teaspoons salt. Right. So this one will be get name. This will create our recipe class, and this is pretty much all I think we should put in here. Now, there's some code in here we haven't really talked about, but there's this string builder tool that we use, which is basically a way that we can grab a bunch of text and store it in a variable that we can then output all at once. And so notice the procedure is basically that we'll be stepping through the list of ingredients and appending to the string builder, which is another complex object, by the way. Kind of like a list, if you will. You know, I think that's really actually a good example, but it just holds strings. We'll keep adding all this information, including some spaces in between things. It'll keep being added to this thing called SB. We just append it. That's the command to add to a string builder. And then when we're all done looping through the ingredients, it will just return the whole string back to where we called it. This is kind of an interesting approach. So we're really kind of introducing another new tool here. There's different ways to do this. Another way, and you could think about this, is I could just use a regular string. And instead of using the append method of the string builder, instead I could just plus equals or concatenate whatever the ingredient is onto the existing string and just keep building the string that way. That's possible too, right? So that's just a matter of seeing it and doing it, you know, different type of code, but this is a chance to show you another technique. This is really a very commonly used one, by the way. All right. Hopefully you guys got that all copied. I mean, I pasted the code for you, so you should be good. All right. So now we're going to go back. Make sure I save that. We're going to go back to our main program, and now we're going to start rewiring this a little bit to accommodate for the change that basically we just made, you know. And so here's what we're going to do. We're going to take all this code here and we're just going to push it down, and we're going to use some of it, most of it, but we're going to move it and change it and reshape it a little bit so you have an alternate version that you're going to be kind of working with here. First, we're not going to need to any longer call in a list of ingredients because that's now built into the recipe. What we need to create here is a list. Does anybody guess what would go here? Of recipe. Excuse me. And we'll call it recipes and we'll let it create the new list. The other thing that we're going to do is we still need to capture basically input from the user that we're going to use to kind of end this little program. So I'm going to kind of show you this later, but go ahead and add this in if you will. We'll put in a string called input. That for now will remain blank. Now I'm also going to start taking some of the stuff that I have here and rebuilding it. And I'm going to flip my whole loop structure because the one thing about this style of loop, and this was kind of like a little bit of a leap to get this logic to work, is it actually would make more sense. I mean, if we're going to do at least one prompting of ingredients, right? Because that's a given. And if you think about how loops work, a do while loop might actually be better here. So that's what I'm going to start building. So I'm going to use the keyword do and then put in our curlies. And the first thing we're going to do is we're going to prompt for a recipe. So here's the code for that. So we're going to enter the recipe name. Notice that we're creating a recipe object now. I'm not storing it in a variable. I'm creating a recipe object and I'm instantiating it. And what is it feeding in? Now remember the constructor for that takes a string. So read line captures a string. It'll feed that in and that will be the name of the recipe. So you start with enter the recipe name, chocolate chip cookies. And now it's created an object and named it at the same time. And that object now also has built into it a list of ingredients that we can now start populating. Okay, so that's the first part of it. Now, there's a kind of another level that happens here. That's the recipe name. That's only going to happen once. I don't want to keep repeating that. Correct? Correct. So, but the other steps that I have will repeat. So we're going to do another do while loop inside here. And now we'll start doing our normal prompts. And then we will be kind of changing how we're doing this. And we're going to store the stuff, switch it, make sure it's all, you'll see what as we're going. All right, so let's do the first prompt first. So let's grab, well, the recipe name we don't need, right? But we will need the ingredient. And then I want to alter this because I want to put that little NA thing in there. So this I'm going to copy and I'm going to drop in here. So we're going to prompt for the ingredient, but we're also going to say NA when done. Next. Now, all of this stuff that I did down here, I am going to hit my little comment marks and I'm going to comment that all out now. Just got to find the right spot to do it right here. And I'm going to be grabbing code. Oops, sorry, wrong spot. I think it needs to go there. And here's where I'm going to start using the input variable to replace some of the stuff that I've done already. So I'm going to grab this from the console here, and we're going to throw it in this thing called input. And now I'm going to write my little if statement. And I'm going to say, and this, I'm sorry, this should be inside the loop. Now I'm going to test it. I'm going to take that input, and before I compare it to anything, I'm going to switch it to uppercase. Why? Because I don't know if they're going to type it lowercase, right? What if they type NA lowercase? I'm just putting it out there, right? So you probably didn't think about that. And this is just kind of a little safety net, basically. Same kind of logic we did before, but you're going to see there's a little bit of an alteration here as we kind of proceed. So same kind of concept though. The if statement's still there. Now we're going to go ahead. You know, and I'm not sure I'm liking this approach. I think, all right, so this is me being kind of wishy-washy, and I apologize for that. I think I'm going to change. I don't like the input name. See, like sometimes I write the code and then I look back at it and go, why did I do that? And I think I'm just going to go like this. And the reason I'm doing this is because I don't want to alter the code that we already wrote tonight more than I already did. Right. So down here, we do have our other variables. So we still have the ingredient. You know, and what I probably should have done is I should have probably just copied those. All right, so fine, I'll copy them. And I'll copy them in the format that we have them, so it kind of jives. And this should be ingredient. Sorry. So that's now fixed. And then I'm going to paste some stuff in here. And then I have to tweak it because once again, I wrote it previously and now I'm adjusting it, you know. So, and then this one was called measure. Right, this is what happens. So I like colon better. I like it like that. Right, this all is still good. We don't want to redeclare these though. So some other changes. Same capture technique, really. If you think about it, it's just gonna do a while loop. But now adding it to the recipe is where it changes. So still inside the if statement, this is assuming they didn't type NA. We're now going to send that directly into a new object and then call the add ingredient class in our recipe. There you go. It should be like that. It's flagging it red, so we might have to actually declare them internally. All right, let me delete those there. There's always a reason why I do things in code. It's still flagging. Okay, interesting. You guys getting the same thing in your code? Let's Control Z that. That shouldn't be the case. All right, I'm still going to roll with it because I think it will correct itself. So let's see if I'm correct as we move forward. And if not, well, then we'll have a little troubleshooting to do. I'm curious to see add parameter to ingredient. Okay, so this is where this stems from. Are we sending them in the right order? That's really kind of what it comes down to. See, we were sending them in ingredient quantity measure. That's what it is. I knew there was an explanation. That's why it's good when you get those red underlines to not freak out, basically. I just changed it to match up how my object was built, right? Still work just fine. Just different order. All right. Once we get to the bottom of that if, now here's where we got to put our while. So our while for the inner do loop is going to check that ingredient converted to upper. And then here we're making sure it is not equal to NA. And then our semicolon. There's the entirety of the new code. And so if you think about this, we enter the recipe name, then we go into this loop, ingredients, as long as it's not NA, quantity, the measurement, add it to the object, keep going, prompt again, keep going, prompt again, filling up our ingredient list. And then they finally go, okay, I'm all done. They hit NA and they're out. But what happens then? Well, that means the recipe is done being created, at least as far as we have it. So now we're going to take and add to the recipe, or excuse me, the recipes, the recipe we just created. All right, so that was kind of a mouthful. And I am misnaming that. Right? No, not add ingredients, sorry, just add recipe. And see, just to give you guys a point of reference here, we created recipe. And as the recipe builds itself, because the recipe in our main program is in a list, we are adding to the list of recipes. Okay, so this goes a little bit deeper than what we were doing before. So now the next step of this, and you think about this, is I could enter another recipe with this structure. So this is where it kind of gets fun. And so I'm going to say, and I'll do a prompt here with this. I'm just trying to save a little time with the copy paste. So it's the console, right? Do you want to enter another recipe? And it's a yes, no. And then now we can enter in our while statement here at the bottom to check the logic. And the logic I have is we're going to do a read line, convert it to upper. And then throw in our semicolon. So here's what's happening conceptually. Now they can enter a second recipe with a second list of ingredients. All right. I think all of our other code is commented out here. Then finally, what we'll need to do is loop to now iterate over not the ingredients, but now we're going to iterate over the recipes which contain the ingredients. So there's the code. And I think all this other code could now be blown away. I'm leaving mine in place because, you know, it's kind of reference, right? So I don't know if you guys are doing the same, hopefully. And I know I'm kind of bouncing around a little bit. But maybe I can do this. If you guys are like screenshotters or whatever, there's kind of almost all the code. I'm going to go ahead and run it and try to prove that it works. Or hopefully it works. Principle it should work because I did get it to work before. So let's call this one sandwich. Right? Ingredient ham, 2 slices. We'll just say mayo. Tablespoon. All right. Now we'll say NA. That's enough for my ham sandwich. Do you want to enter another recipe? Why yes, I do. All right. This one will be my chocolate chip cookies. And we'll start with eggs. That's kind of a weird one. Right? How do you can't really change that one. You need to measure. What's the measurement on that? Should you just leave it blank? I'll leave it blank. What else do you put in chocolate chip cookies? Butter. Et cetera, et cetera, et cetera. So you guys just imagine I'm putting in all the ingredients, right? I'm just going to go ahead and type NA, enter another recipe. This time I'm going to say no. And then here is my output, my sandwich and my chocolate chip cookies. All right. So it was a little bit of work, but we did get it there. And I think that this is really kind of an interesting little exercise, especially in the way that we changed it. Now you can always, like I said before, you could use the simplistic version and turn that in because it technically does exactly what is asked for, you know, so you don't really have to make it complex. That was like adding like 3 or 4 lines of code. And remember, it is embedded in the video, so you can go back, you know, tomorrow when I post it, whatever, and then take a look and adjust. And then if you like this idea of creating a second class file, let's review the class file. So we started with a list of ingredients. I'm just going to zoom out so if people are watching the video, they can get all of it at once. And we formed that as a class. We had a constructor, an overloaded constructor. We had a get name, get quantity, and get measurement. Then we built a class of recipe, and that includes a private list of ingredients and a name for the recipe. That also has a constructor that accepts the name and instantiates a new list item, or the new list inside the list, if you will. Then we have an add ingredient method, the get name method, and then we also introduced a new concept here with string builder, where you keep appending to a string and then you can output it all at once in a print recipe method. Right, so we got those all to work, and then we put it all into our program here. And in the program, we started by first creating a list of recipes, so a collection of recipes, if you will. Set up a few variables up there at the top. Did a couple of do loops, one encapsulated inside the other. So we prompted for the recipe name, then we went into the inner one. Did kind of the standard loop that we did before. We just switched it to a do while loop. This time we were adding the ingredients, and we did have to reorder these to get those correct. Then once that's all done and they type NA, it gets added to the recipe list. And then we prompt for another recipe. And if they say yes, we repeat the process. If not, we iterate over the contents of the recipes in the recipes list and put it on the screen. So that would be the entirety of the program. And I'm just going to pause the recording here for just a sec. All right, now that we've completed the lab, we're going to switch over to working on the assignment for this unit. So I'm just going to jump down to 6 here and pull up the assignment. And let's read through. It says create a program to simulate a vending machine. It should have a class called item. The item class should have fields that store the name of the item, quantity in the machine, and price per unit. The main program should use a list item to store the inventory in the vending machine. At program start, the user should be able to fill the machine with items to vend. When they are done filling the machine, the program allows the users to purchase from the machine. When the users are done purchasing, the program should print out the inventory remaining in the vending machine. It should also print the amount of money the machine collected from item sales. All right, a little bit of a sample program run here, so we should look at that. So you'll get prompted, enter item to stock, Snickers, quantity, price each. I'm hoping you guys notice the pattern here, right? This is not that much different from what we were just doing. It's just kind of renaming things, right? And creating new objects. Same sort of process. So it's good. The reason I'm doing that is I want you to identify those patterns, so you can sort of copy from what we've already done. All right. Then they have this like fancy ASCII art here, right? They type in their NA and they pop out. And then vending machine pops up, and it has a menu basically showing 1 Snickers, 2 trail mix, 3 M&Ms, etc. And so you should fill that, and then you'll get prompted item to buy. You type in the number of what you want, and if you don't want any more items, you type the -1 to pop you out. And so you can, buy a Snickers, buy some trail mix, buy a Snickers, and then type your NA. I think it would be -1 to end, actually, right? Yes, this should say -1 here. All right. Then more ASCII art, and then you do an output that shows the inventory in the machine. So like if you put in 12 Snickers and sold 3, there should be 9 left. And if you put in 10 trail mixes and only 1 sold, there should be 9 left. So what this tells you is that part of the process of when you're making the sale is you're going to subtract, or you could do the minus equals thing from that property of the vending machine. That would be the trick. And then the $6.80 that's collected from sales, that's also tabulated as you prompt the person to buy the item. So like as they do the number, you know, whatever the price is, you just take that value and add it to another property of the items in the vending machine. You guys are kind of feeling where I'm going with all this. So I know that this is a little bit of a taller ask. And like I said, I'm going to do a build on this after class. And it's probably, real frankly, it's probably going to be tomorrow morning, you know, when I do it. And then when I'm done with it, I will post the video so you do have a solution that you can look at and follow along with. But I would also appreciate it if you guys gave it a wholehearted try to solve it on your own. You really do have all the pieces in place, even with just what we've done in class tonight, to make it happen. Right? You don't need to make it necessarily complex in that, you know, does the vending machine, I mean, how many files do we need here? I mean, you should think about that. Does the vending machine hold items? It does, right? And does that vending machine hold multiple items, you know? So this is kind of how it's all in how you kind of see it. The way that I see it, I would make one class file that would hold the items, and then the program would kind of drive the rest. That's how I would do it. You could put that class file in the program file and it would work. You know, if that's easier for you to do it that way, that's absolutely fine. All right. Let's call it a night, folks. We got 5 minutes left, so the recording will end here.